In this lesson, we're going to talk about really, really, really large numbers and scientific notation, putting these large numbers into scientific notation and taking really large numbers out of scientific notation and putting them in standard form. So first one, an astronomical unit. That's the average distance between the Earth and the Sun. It's about 93 million miles. So here I have 93 million written out. We want to put this in scientific notation. The first thing we need to do is be able to identify where the decimal point is. When we have a number, the decimal point is always at the end if we don't see it. If you don't see a decimal point, it's always at the end of the number. We want there to be only one number to the left of the decimal. Remember, that first term has to be between 1 and 10. So I'm going to move this decimal to be between the 9 and the 3, but I'm going to count how many times it takes to get there. 1, 2, 3, 4, 5, 6, 7. It took 7 kind of loops or 7 jumps to get to where that term is going to be between 1 and 10 with 9.3. And it's always times 10. Now comes the exponent. We had to count how many loops because that many loops, that number is going to be our exponent. Now, 93 million is bigger than 9.3. So we went from a big number to a small number. When we go from a big number to a small number, that means our exponent is going to get bigger. So that is going to be a positive 7, since I moved the decimal 7 units to the left. So here's how fast light travels. No decimal there. The decimal point is at the end. We want to express this in scientific notation. 1, 2, 3, 4, 5. Remember, I only want one number to the left because that first term has to be between 1 and 10. And I have to put all these numbers that are there. I have to put the 1.86. I can't just stop at 1.8 because that's a totally different number. So I have to put the 1.86. And then it's times 10. And again, I made the number in front smaller. So my exponent gets bigger. I moved it 5 times. So it's an exponent of positive 5. So now let's go backwards. Let's take a number in scientific notation and put it in standard form. Now my exponent is 10 and it is a positive 10. When we start in scientific notation and we go to standard form, positive 10 means to move our decimal to the right 10 units. So right there, I moved it to the right 10 units. For all my empty loops here, I add zeros. So this number is going to be a very large number. 13,700,000,000 is the number in standard form. So the moon is this many miles from Earth. There's my decimal. I have a positive 5. Since that is a positive 5 from scientific notation, I have to move to go into standard form the decimal to the right 5 units. And all these empty loops get zeros. So the moon is 240,000 miles from Earth. So when we are describing something very large in scientific or standard form, something other than astronomy related, what I think of a lot of times are the athletes or some of these really large contracts you'll see with like TVs and or like cable channels and the richest people in the world, so how much somebody's worth. A lot of times that's in scientific notation. So when we talk about athletes' salaries, you'll often hear that they signed a contract worth $3.25 million. That is scientific notation. $3.25 million. That's how much money they are set to make. So here we go. In April 2020, 4 countries' total COVID cases reported are represented by the table. We're going to estimate each number in scientific notation, and it says estimate. It says use a single digit for the first factor. So estimate means to round. So we're going to round to the nearest digit. And here are all of these related, estimated in scientific notation. You can see 1, 2, 3, 4, 5, 6, 7. That's where we get our exponent. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So those loops are how we get our exponents. And I have already written those out. So there's a couple ways to go about these. We're going to answer these statements true or false. First one says country A is about 40 times as many cases as country B. Well, there's two ways to go about this. One way, we can divide them. If you want to find out how many times bigger something is than something else, divide the two. So I took country A and divided it by country B. So 8 divided by 2 is 4. When we divide like bases, we subtract our exponents, so I get 10 to the first. So when I'm putting that into standard form, that means I need to move my decimal one place to the right because my exponent was 1, which gives me 40. So that proves that this one is true. The other way we can do it is we can take country B and multiply it by 40. 2 times 40 is 80, times 10 to the 6th. This is not scientific notation, so I need to take my decimal, which is after the 80, after the 0 and the 80, move it one place to the left to make it 8. And I made that number in front bigger, or smaller, I mean, by one loop, so I need to add 1. I need to make my exponent bigger by 1, which makes it 8 times 10 to the 7th, which is what we get for country A, so that is also how we can tell that this is true. All right, country C has about 30 times as many cases as country B. Again, there's two ways to go about this. One, we can divide them. I took country B, or country A, and C, and divided it by country B. And I get 3, and then times 10 to the 0, which just equals 3, not 30. So this should show that this one is false, but another way to do it is to take country B, which I did right here, and multiply that by 30 to see if it equals country C. Well, 2 times 30 is 60, times 10 to the 6th. This is not scientific notation yet. I'm going to take my decimal, move it 1 to the left, I get 6. Now when I move my decimal, I have to adjust my exponent. So I made the number in front smaller, so I need to make my exponent bigger by 1. I get 6 times 10 to the 7th, which is not what country C is. So again, that shows that this is false. Here, country B is about 5 times as many cases as country D. So I went ahead and divided them. I took country B, divided it by country D, 0.5 times 10 to the first. Let's put this in standard form. This positive 1 tells me to move the decimal one place to the right, which I do, which gives me 5. So far this is true. Let's test this out. I took country D. Let's multiply it by 5. 4 times 5 is 20. We leave the times 10 to the 5th alone. Not yet in scientific notation yet, so I need to move my decimal one place to the left to make the number in front smaller. And since I only moved it 1 to make it smaller, I need to make my exponent bigger. I get 2 times 10 to the 6th, which is what country B is, so that also shows that this is true. So there we showed two ways of doing it: dividing numbers in scientific notation and multiplying with numbers in scientific notation. All right, last example here. Scientists are observing the number of ants in a colony. Colony A has 4 times 10 to the 6th. Colony B has 2 times 10 to the 5th number of ants. The number of ants in a colony, how many times are the number of ants in colony B? So how many times bigger is colony A than B? So let's take colony A and divide it by colony B to see how many times bigger. Well, we do the numbers in front first. So 4 divided by 2 is 2. When I divide like bases, which I did here, my like bases is times 10 times 10. I subtract my exponent. 6 minus 5 is 1. So 2 times 10 to the first, let's go ahead and put this in scientific notation. That positive 1, or in standard form I mean, that positive 1 tells me to move the decimal one place to the right. So colony A is 20 times bigger than colony B.